Welcome everyone to working with video and tracking datasets in FiftyOne. If you've been looking how to get started with tracking datasets, or you're just interested on how you can upgrade or level up your computer vision workflows, this is the place to be. In this tutorial, we'll be covering a couple things with video and tracking datasets, but mainly loading the dataset is to detections and trajectories into FiftyOne, computing, storing, and analyzing per frame trajectory statistics, visualizing the interesting object trajectories within our dataset, running a pedestrian tracker on the dataset and then loading our inference results on top, and assessing our tracking based on our model to see how well we did. In order to get started here, if you want to follow along, we do have the link to this notebook below, so you can code along with me. We need to get started by installing FiftyOne, as well as having these libraries available, namely NumPy and Pandas as well, on standard Python stack. The dataset that we're going to be using is the MOT17 dataset. It is somewhat a pillar of the tracking dataset community, and it has been a good staple to work with for the past 5, 6, 7 years now at this point. So we can download the dataset. It's not very big, 5.5 gigs, unzip. Now this dataset does come as images originally. However, we want to be working with it as a video, as it more closely relates to the problem and it's easier to visualize for us. So we can use some FiftyOne utilities. I'm going to briefly pass over this, but basically you can re-encode these videos, stack them up, so that way we're working with a video dataset. We're also only going to be looking at 2 movies from this dataset, just for simplicity's sake. Afterwards, we have a directory full of videos we can load via FiftyOne dataset from directory. We call it a video directory. And then we can ensure our frames to make sure all our videos are allocated correctly. The samples have been created. Their frames are stacked up correctly. And our dataset's ready to go. We name our dataset MOT17 and then set it equal to persistent. This way, any changes we make to our dataset will be saved to our disk. Now, FiftyOne is a logical library. It's not going to be copying any files or duplicating any of your files. But this just lets us save all of our things like labels or certain views to our data set so that we can come back and see our ground truths and such. We could print out our first sample in our data set like so to see that our data has been properly loaded in. So we can see that the first sample is a video. We can see the file path here, as well as some metadata, right, with time, frame rate, things like that can be important for later. It's also important to call out that whenever you are grabbing the frames, we can grab frames by calling sample.frames. However, frames start with 1-based numbers, not 0, as there's only one first frame, that's frame number 1. There is no frame 0 in this case. Now to load in some detections, I'm going to go over the code piece by piece, and then we'll run the code. Actually, I'm going to run the code right now, just in case it takes a while. And we'll talk about the code piece by piece. So the first thing that we want to do is note that MOT17 comes as CSV files. There's associated detections and classes and tracks with each bounding box. So we have our ground truth columns here. These are all the things that we're interested in grabbing from our CSV. This will be the frame that we're currently on, all the tracks. This is the bounding box, as well as some labels, metadata such as the visibility, the class, and the flag. Now, there are a lot of classes within this dataset that we currently don't care about or are going to alter for our use case. So we only currently care if they are a person, vehicle, or a crowd. Now, there is like sitting person or still person in this dataset. Static person is what it's called. We're just going to make that person the same way so we can sort through our dataset easier. That being said, now we have this set up. We define a function to read the detections from our CSV. This is very standard from a custom dataset importer standpoint. So if you are looking from the point of view that you're not having a Cocoa dataset or a Pascal Vogue dataset or one of these like highly standardized datasets, this is very standard about how you would load a custom one then. So what we're going to do is we're going to first grab our bounding boxes, right? So we're reading detections from the CSV. So we load our frame from the CSV. This DF is the data frame that's holding the CSV. We're going to load all of our bounding box numbers, such as the X, the Y, the width, and the height. Make that a list. We are also going to grab all the tracks, the visibility, and the classes for each frame. So basically, read the textures. You're going to pass the CSV and what frame we're on. And then for that frame, let's grab every detection from that frame, right? There could be 10 detections, 10 different people, whatever it might be. Let's grab all of them. We're going to zip it up, all their associated ones together, and then pass it back. So now that we have this function defined, we can look, we're going to say for movie and for each sample within, our data set here. We are going to get our CSV, put it into a data frame as we talked about. This is, we're normalizing our data frame, right? So the data frame gives X, Y, and width height as non-normalized. So you imagine like 640 is the max value. We just want to normalize that by our image width and image height here. That way they're all less than 1, right? And this is just how FiftyOne accepts bounding box information. After that, we're going to say for frame, right? We're going to load in every bounding box. And then for every bounding box, we're going to then add all of our bounding boxes back to our frame and then save it down here. So basically for each frame within our sample, we can reword this as for each frame in our video, get every bounding box based on this function that we defined, get every bounding box for that frame, and then add it to that frame as we see here. After we add all of our detections per frame, we move to the next frame. Once we're done with all the frames within our sample, we save our sample. So we can see down here, we have some print statements to help us get through. So we can see that we successfully loaded all of our detections. Now it's important to note, since we have saved our data set, if you're going to come back to this data set and do some kind of analysis, you can always just load your data set from here and it's going to have your sample saved the same way. We don't have to do this step every time. So we can actually now launch our app and visualize our data set. We've done 2 steps here. We've loaded our videos into our data set, and then we loaded our detections on top. So we can click on one of these videos and see. I can play the video for you. And we can see we have all of our different tracks, right? So we see here that we have all these different person labels. And there's ways to alter your config if this is a little too noisy for you. But we can see each person has an associated track. So it's person 32 and person 33 and person 35. Person 3 has been here in the frame for a long time. We have some person 26 back there and so on. And we can actually look through this, right? We can see all the different labels we have. We have 30,000 different labels. We can do based on index. So if I'm only interested in person 1, we can see person 1's back there. Likewise, I can go to any range of people. So maybe I only care about the first couple people that we saw or so on and so forth, right? I can also only show the people, right? There's some other detections in here that are not people that we don't care about. We can switch these around. Okay, awesome. So now that we have our data set loaded, we can take it to the next level. The next introspection that we might be interested in is looking at our trajectories. Our trajectories is the index or the track. Imagine person 2, right? This is the person you have signed as person number 2. The trajectory would show the start and finish of person number 2's journey in your frame, like in your view. So from, they come in on the left side, they walk to the right side, that is their trajectory. So we can actually look at these trajectories and calculate some statistics and understand a little bit more about our trajectories. So here we can see that we have, in our first video, as we just looked at, there's 83 different trajectories with min-max lengths of 1 or 600. So sometimes there's only there for 1 frame. Some of them have left pretty much the entire video. They're there. And we can see for each one, all of our different lengths. Another very interesting statistic when it comes to tracking data sets is speed. So I'll show a very quick way how you can assign speed values to each trajectory. So we're going to calculate the centroid. Centroid is basically the center of your bounding box. We're going to put a key point in the center of the bounding box, and that key point is going to hold our speed values. So very similar as before, for each sample within our data set that has a person label, essentially within the ground truths. So if there's no person in that frame, we don't care. As we saw before, we're going to get the metadata again for image width and height. And then we're going to create this key point. The key point is the centroid of the bounding box, we're going to keep the label, keep the index, to make sure that everything is the same. So for each frame, every bounding box in your frame, we're going to put a key point or a point right in the middle of the bounding box. And then we're going to give it all the same label and tracking information. The only difference here is that using the key points over time, we can now calculate how far they've moved over the sample. So we can see last scene and then this points one. We're basically calculating from the scene we saw last time, right, or from the last frame, how far has our key point moved since then? And then we can calculate this speed or velocity metric and then add it to the key point as an additional field, right? So key points don't typically have the field speed, but with 51, you can just add it right in. We have this, so basically said if it's the first time you've seen it, it's none. If it's the second time you've seen it, I can calculate, the difference between, frame 1 and frame 2 and see how fast it moves across. We do this across every bounding box in our entire data set and add these key points in. What's neat about this is it really doesn't take that long. So you can think that we just saw that we had something like 20,000 bounding boxes or something like that. And we can see we can just churn through all of our frames here and add all these speed and statistics to it. What's neat about speed statistics is you're going to be able to get some insights about like what is our fastest or slowest fields across, right? And we can think about things about like, are we accurate on trajectories that move very fast? Are we accurate on trajectories that stay the same, right? One of the key points of an evaluation metric of a tracking data set is not just, am I putting the bounding box across the person, but also am I having any re-IDs or labels or index switching, right? Where I thought person 1 and person 2 were, left and right, but, over time I switch their labels because I don't know who's who anymore. Is just as important within a tracking data set. So we can call dataset add dynamic frame fields. This basically allows us to visualize speed within our app. And then now when we go back in, we can see, remember there was 30,000 labels here. We now have key points on each single bounding box. And now we also have the ability to sort based on things like speed, right? So I can show only maybe my 50% fastest ones. These are only for key points, right? So we can turn these off. So show me only my bounding boxes that are moving very fast, right? So we can see not many of them are moving too fast. These, elderly folks are moving pretty slow. But as we move on to the video, you'll see we'll have some maybe closer to the camera move faster. So here is a great example. Okay. So since we can now filter on speed, we can also filter through the SDK and do some things here. This is a very long-winded way, but basically what we're doing here is getting some average speeds. We're getting the max speeds. So we're looking through our entire data set to get these things. So we can see that the min speed is 0. We have a trajectory that never moves. Our max speed is 59. We have a trajectory that moves pretty fast. And we can see which trajectories there are. And then the neat part here, we'll stop and pause here, is one of the unique things that we have for tracking data sets at FiftyOne is this function called two trajectories. Two trajectories will basically create a view, if you're familiar with 51 views, that will only show the trajectories of what you're interested in. So we can print this out. And you can see we filter these labels to make sure that we have the index. So we are filtering based on our labels. We're looking for the index for our slowest and fastest. So we're grabbing two indexes. And then for those two indexes, let's push them to trajectories. So we see we have two clips. These clips are very similar to the rest of our videos, where they're still able to be played. You can see all the same fields. However, when we load them in, we can see that we have two different sets of videos here of the same one. Video 1, we can see person 1 here. He never moves. So he's sitting on his bench. He's having a great time. They never move. And then for person 2, this is actually, I know for a fact, the woman that comes across at the front, as we saw before. This is our fastest trajectory. So, next step here, if you're interested in loading your inference results, you want to understand how your model is predicting on your samples, how well it's predicting, how accurate it's predicting. We can actually load inference results on top and easily also inference on top of our 51 dataset. So we're going to be using a YOLO V8 bot sort stack. So for tracking datasets, you usually need a stack of models or algorithms. So we're going to be using a YOLO V8 detection model. And then on top of that, we're going to use a bot sort on the back end. So we can install Ultralytics. This will actually be all prepared for us. So we can install Ultralytics, import Ultralytics. Then you can just call Ultralytics ULB5 here. And then it has a built-in track. So let's load this in. And we're going to inference real quick. So we can see we actually inference through each one of our frames. This might take a while. I'll pause the video and come back. Okay, now that our detections are ready, we can load them into our data set. Following the similar pattern from before, we're going to make sure that we loaded our width and height, just so we can normalize our bounding boxes. Moving forward, we're going to grab our boxes, and then for each box within our boxes, we are going to make sure that we are normalizing our bounding box. We're going to grab the index, the confidence, load this detection. Notice that when you load detection to added index or confidence, we can just add them in, and then we append them, and we save our sample. Notice that we're loading in each frame, and then keep on going forward, and we can print this for each frame. So we're going to run this real quick, and we can see we're going to move through. Now, some things to keep in mind whenever we index, it's not necessary, or sorry, some things to keep in mind when we're inferencing. It's not about getting the right index necessarily. So it's not about saying person one is person one. It's more about saying is the person, you might say person one, I might say person two, but am I holding that track throughout the entire time? That's what is the most important part. So we can pull this view, load it, you can check it out, and now you can see that we have inference results on top of our ground truth. So we can take any of these ones out. So this is only our inference results. See, we do have some index switching here happening. As you can see, a lot of person ones should only be one person one. So our model's not perfect, and that's fine. Tracking is a hard problem in computer vision, so we're not elite. So it's all about evaluating, see how much more we have to gain, and where we can go from here. So we're going to do a couple things here. We're going to do 2 frames and make sure that we have a frame data set ready. Oop, I already have one called this name. I apologize. I'm going to call this one YouTube. Now we have this frames data set. It's the same thing as our tracking data sets, only the frames this time. We can see how many different trajectories we have based on ground truth versus our predicted. So our predicted has a lot less trajectories than we would hope. Moving forward, we are going to do an evaluation. So in order to evaluate here, we're going to look at the predictions and see if any of our key points are jumping too far, right? So before we had this idea of speed, and we can track our speed throughout our trajectory. One way that we can evaluate our models here is see if our key point jumps, let's say from the left side of the screen to the right side of the screen. Well, I know my person, whoever I was just evaluating, didn't just teleport, right, from the left side to the right side of the screen. Most likely a mistake. So we can see here, we can print out any of these suspect ones. And then as we move forward too, we can now update our labels. So we make sure that we're tracking our indexes correctly. And finally, you can run the built-in evaluation here for FiftyOne. So we're going to evaluate as you would evaluate like a map score, essentially. And this will give you your typical classification score. But we can also talk about, like I said, the trajectories that jumped and take a look at those. So here we're going to take a view at our large boxes and see how we did. So we can see across this trajectory, we're switching, right? So here we're calling this, see the labels here, we're calling this person 29. But as we go down here, we're still calling this the same person. Very clearly, this is not the same person, right? So we have switched, we actually switch again down here. So we're not maintaining our tracks, we're switching again. My point I'm trying to get across here is using this view that we've made, we can actually see all of our trajectories switch, while this should only really be one person, we're bouncing around a lot, right? And that's not ideal here. So from here, we can then take these, so I can like look in, right, and say, okay, person 29, right, this is an incorrect one. I can say, you know, this is suspicious. I can change this to like 1 and 29, so on and so forth. Say, hey, I saw this browsing within 51. This is suspect. And then I can filter and then say, you know, we need to look at this closely. We need to reevaluate our model. This is the one that is performing the worst, right? And then it's all about taking it from there, right? Tracking is a very unique problem where maybe it's not my YOLO v5, right? So if I, let me backtrack a bit here. If I go to here and I look at this video, I'm not going to look at the ground truths. I'm only interested in my inferencing. I can see that my bounding boxes are pretty good. It's more of my tracks that are the issue here. So that probably leads to my sorting algorithm, whatever my feature extractor might be, or however my algorithm, like my Hungarian or matching algorithm is doing, is not performing well. And that's how what we would want to address here in this case. But, you know, using FiftyOne, we can see what type of bounding boxes are we predicting wrong on, how often are we jumping tracks, which tracks tend to jump, so on and so forth, to get that introspection into your tracking data set. And that's all what it's about. I hope this video has been insightful for you and has been a great starting point for your tracking data sets. Hopefully you've learned how to load, you know, inference, add detections, as well as introspect tracking data sets, so that you can level up your computer vision experience in the future with FiftyOne. If you ever have any questions about tracking data sets, or you want more additional getting started tips, or have any questions about how to take it even further than what we've seen in this video, hop over to the community Slack for FiftyOne, where we're more than happy to dive into, you know, even the most in-depth computer vision problems. I appreciate you guys and everyone for staying here throughout the video. And if you ever want more tips and tricks or more insights on how you can level up your computer vision flows like this, stay tuned for more videos to come. Thank you, everyone, and have a great week.